All right, so let's start off with the homework. I gave you a triangle. I asked you to find the missing sides using our law of sines. All right, so okay. So here we have an angle and two sides. So again, like we said yesterday, this is an SSA. So we have to take specific steps here. We can't just go and find whatever we want, right? So we have angle A and we have side A. I have side C. So the first thing I want to find is angle C, right? So we are going to set it our proportions. So because I'm looking for the angle, I'll do the sine on top. It doesn't really matter though. So we'll have, nope, that's not supposed to be a circle. There we go. All right, so our first proportion should be the sine of 88 over 26 equals the sine of C over 21. That tells me the sine of C is going to be the sine of 88 times 21, so I'll put that in front, all over 26, right? All I really got to do is multiply by 21 over here. So we calculate that, and I get the sine of C is equal to 21 sine 88, 26. Okay, we're going to get 0.8072, I'll say. All right. So I don't know if I mentioned this yesterday. When we're doing this, again, we want to be as accurate as possible. So although I wrote down 0.8072, right, that's just not an estimate, but that's a rounded number, right? So, you know, the real decimal is 0.8072000283, and then obviously it keeps going on forever. So for our next step, right, we said we need to get the C alone, so we do the inverse sine. So typing this would be okay. But another thing that you can do, right, with this as with the 0.8072 as your last answer in the calculator, you can hit the inverse sine, and then usually if you hit the second and the minus sign, I don't know if you can see it. No, it's kind of blurry. It plugs in the answer. All right, so that's sine -1 with the answer. Sorry about the blurriness. That takes the whole decimal, everything that the calculator knows, and it plugs it in. Right. So plugging in the answer, we get angle C is equal to 53 point, I'll say 8. For degrees, we usually only need 1 decimal point. So just to compare, if I took the inverse sine of 0.8072, the rounded number, we get pretty close to. We get 53.82, right? So the more decimal points you use for inverse trig, the more accurate you are. So we just found our angle C is 53.8 degrees. All right, so next up, we would have angle B, right? That's pretty simple. We add up our two other sides and we subtract that from 180. So we get angle B, 180 minus 88, 53.8. We're going to get 38.2. Right, and now that we have angle B, we can set up a proportion for side B. Now, let me just put, this was our second step. And our third step. So, you know, like I said before, I'm going to stick with using A and side A as my first proportion. And I'm going to flip it back around because we're looking for this side. So I'm going to have 26 over the sine of 88 equals side C, which we don't know. I'm sorry, not side C, side B, over the sine of the angle we just found, 38.2. Right. So again, it doesn't really matter what you have on in the top and in the denominator, as long as you're consistent. Personal preference, I like putting the variable in the numerator. It's a little less work, less chance for, you know, a silly mistake. So to cross multiply and divide, I get b is equal to 26 times the sine of 38.2 divided by the sine of 88. So I can plug all that into the calculator. 26 sine of 38.2 divided by the sine of 88. So there, we get 16.088. So for that, I'm going to say 16.1. All right, so we found the 3 missing parts. So again, side B, 16.1, angle C, 53.8, angle B, 38.2. Any questions? All right, so let's move that off to the side. We don't need that anymore.
Wait, can you put it back, like, really quickly?
Yeah, sure.
A little tiny bit more.
Actually, you know what? We're going to hold off on that right now.
I got it. Thank you.
You're welcome. All right. So yesterday I did mention there are some interesting cases when we're looking at triangles with the law of sines. So I did want to introduce a no solution case just to see what would happen. So we're going to solve a triangle where A is 15, B is 25, and angle A is 85 degrees. All right, so you may see a situation like this where they don't give you the triangle, they just tell you the measurements of certain parts of it. All right, so you're going to draw out your own triangle. Obviously, it may not be to scale, but that's okay, just as long as you kind of have some shape to reference. Right, so I'm going to have A, B, C. It doesn't really matter where they go, but that tells me side A over here is 15, side B over here is 25, and angle A is 85 degrees. So from the law of sines, I can't do anything with C yet, so I'm going to have to start off with angle B. So let's set up our proportion. So I have the sine of 85 over 15 equals the sine of angle B over 25. All right, so everything pretty straightforward right now. We do our cross multiplication. I get that the sine of B is equal to 25 sine of 85 over 15. I calculate this. And I get about 1.66. I will say 1.66. Before we go any further, we've already kind of encountered a problem. If you try to plug this in, right? If you tried to solve it and say the inverse sine of 1.66, you get an error, right? That is because we cannot take the sine, the inverse sine of a number larger than 1. That's not how it works. All right. So with a case like that, we would have no solution. Okay. The information that they give us would not produce a triangle. Right? If I really wanted to draw out this information, I wouldn't have this because obviously that's not the situation I have. Right? If I'm trying to be a little more accurate, if I set up an angle of 85 degrees, that's almost a right angle. Well, that's not perfect, but that's close. And no matter where your B is, 25, if it's up here or down here, if I have an opposite side of 85 that's only 15, it would never meet. Okay, so here we've seen it mathematically why it's impossible. Okay, I can't take the inverse sine of 1.66. Right? So if you encounter something like this, where you're asked to solve a triangle with certain information, and you plug it in and you get an error, that is a valid solution. I mean, it's not a valid solution because it's wrong, but it tells us that we do not have a triangle. There is no solution. All right, so I just wanted to show that to you. Any questions about that? All right, so again, if you encounter a problem where you get an error, double check your work. You know, make sure you didn't accidentally flip something, the 25 and the 15. But also know that that means that we may not have a triangle. Okay, so the last bit of sines that we're going to deal with is finding the area. So normally, we have a triangle, and this is my base. Oh, let me just choose a different color just so we have it. The base here, all right, and then we have this line here, this perpendicular line, and that would give us the height. All right, so normally the area is 1/2 the base times the height. That's how we normally have it. But sometimes we're not given the height. Sometimes, it's hard for us to calculate it. If I wasn't given the height in this triangle, I wouldn't be able to calculate. I wouldn't be able to solve for it. There are some situations where you can calculate the height, especially if you're dealing with a right triangle. Right? If you knew this side and this side, well, you can find out this side using Pythagorean theorem, and that would be your height. Right? This would be your base. But again, that's not always the situation. Right? And then just for reference to, for an obtuse triangle, I think I showed this yesterday. This would still be my base, but now my height is on the outside. Right, so especially in this situation, it'd be real hard for me to find that height. Because, I do have a right triangle here, and I might know this, which would be the hypotenuse of that right triangle, but there's really no way for me to calculate what this bottom dotted line is. Right, so that'd be almost impossible to find the height. Well, luckily, through the law of sines, I'm not going to bore you with it, we can find the area. Okay, so the area for any triangle, or in this case, oblique triangles, Well, the base, I mean, that's going to kind of stay the base, and we have to deal with the 1/2 still. But the height, we can calculate using trigonometry, right? So if this was my angle over here that I was looking at, whatever name that was, so that's another part. These are all going to be interchangeable depending on what sides we're given. So I'm going to give you a couple of equations here. So here, though, let's say 1/2 the base, so we still have that. But now my height, well, that depends on, so I'm just labeling the other sides. The A times the sine of C, that would give me my height, right? And that's just using basic trigonometry. The sine is the opposite over the hypotenuse. So doing a little, algebra, I get that the height is equal to A times the sine of C. Why does it keep doing that? I'm not trying to draw a circle. All right, so I can say that the equation is 1/2 AB times the sine of C. Well, what happens if we're not given this information? Well, luckily it's interchangeable. I can also say that it's 1/2 BC, the sine of A. Or, again, if we're given other information, I can say it's 1/2 AC, the sine, oops, that's ugly, of B. So I want you to notice the pattern here because that's going to help you out. Whatever two sides that you're dealing with that you have, you need to make sure you have the other angle. Okay, so notice I don't repeat any variables, right? None of my sides or opposite angles get repeated. So if I have side AB, then I need angle C. If I have side BC, I need angle A. If I have side AC, I need angle B. Right? And then when you're given information, you just need to know these different forms. And it's just a matter of plugging in and calculating. Right? So yeah, we got enough time. Let's look at one example. Let me copy that. All right, so I'll leave those so we got them at the top. Yeah, that's good. And let's look at this example. Find the area of a triangular plot of land with one side of length 90 meters, another side 52 meters, and an included angle of 102 degrees. All right, so there's something I want to break down there, but first let's draw it out. So again, obviously, I know I have an angle of 102 degrees, so it's got to be some kind of obtuse triangle. Okay, it's not going to be drawn to scale. Don't stress yourself over the accuracy of the drawing, but it does help us to draw. So one side is 90 meters, so I'll make the larger side here 90 meters. The other side is 52 meters. Now here, an included angle. Okay, you probably haven't seen that word since geometry. Included means that it's in between two known things. So they're talking about the angle included between these two sides. So this 102 degrees would go here. Right? And this is the setup that you're looking for. This is the setup that gives us what we have here. So no matter how I name this, okay, if I call this A, B, C, you can name it however you want. It's going to work out. So this is little a, this is little b, this is little c. All right, so I have sides C and B and angle A. So for this particular example, I'd be using this formula. But again, it depends on how you set it up, right? If you called this A, this B, and this C, you would just use a different form depending on, you know, where you put your variables, your points, your vertices. All right. So don't get caught up on that part. Put the letters wherever you want. All right. And then it's just matching here. So again, the picture here is what we're looking for. Two sides and the angle in between. So the area is going to be 1/2 of the two sides multiplied together times the sine of the angle that goes in between them. All right, and all that's multiplication, so you can just plug it into your calculator. 1/2, you can do 0.5, so 0.5 times 90 times 52 times the sine of 102. So I get the area is about 2,288, let's say 0.9. Right, and we're talking about area, so now our units is going to be meters squared. So again, just real quick, you know, if I change up my letters here, so let's say I made this A, I made this B, I made this C. So this would be side B, this would be side A. I have A and B and angle C. All right, so again, I'm just showing you here that it doesn't matter how you set up your letters. Okay, you can use any of these and it kind of works that way. Right, in this case, we'd use this first one. Sometimes they might be specific, like the last example that we saw, where they tell you side A is 15, side B is 25. All right, then you have a little more guidance. But if you're just told the information, you can set it up however you'd like. All right, any questions?